And I am very excited to be here. It's after 2.5 months, my enthusiasm is just going up. I still think this place is amazing, and I'm really looking forward to the next few years moving forward. But as Steve mentioned, tonight I'm kind of coming to you as a practitioner, and I'm gonna give a lecture actually I've never given. And you know, I think at certain points in your career, you know, you're kind of deep in the trenches working on some specific project or some specific research, and then other times you're kind of backing out and you're reflecting on what you've been doing. And that's sort of what I use this lecture to do, is to kind of step back and look at what I've done in our practice, what our practice has done since it began. So the structure of the lecture is literally a kind of journey from the very beginning of our practice up to what we're doing now and what we're actually trying to kick off as a next phase. It's a lot of stuff. I mean, if I start, you know, dragging on, I'll just accelerate it. But I'm going to start at the very beginning. And the first probably 10 years, I'm going to go through some projects very quickly, just highlighting, and they're old projects. I mean, some of them are kind of funny. You know, you see computers with big CRTs, but I'm just going to highlight in those projects what we carried forward, what was important, and what was you know, part of our kind of trajectory forward. When we started practicing, I don't know, 3 or 4 years out of school, you know, at that time in New York, you sort of made a decision. You either were just going to do big competitions and try to win a big commission and then kind of launch your career that way, or you started doing smaller commissions. In New York, it was usually interiors because there's not much, you know, new construction for small firms, or you taught, or a combination of those two. Usually you taught because it's the only way you could make enough money to exist. But we wanted to do all three. So the first part of our career, we were doing competitions, and we were also, you know, building at a very small scale, but still building because we love to build. So this is the project that really launched our career. It was a competition, open competition for a convention center in Japan that we entered. There was an invited list of 4 Japanese architects. Actually, there were architects from around the world, and then there were 4 that came in from an open selection, like 600 entries, and we got shortlisted, you know, somehow. So it was a great experience. It really did, you know, it made us confident that this was going to be a viable career path, that we were going to win these competitions all the time and get shortlisted and kind of do that path. But, you know, it became apparent that that's a tricky path. And so we continued, as I said, to build at the same time we were doing competitions. So I don't want to explain each one of these projects, but you know, the idea here that I think resonates still with me now, and I haven't presented this project probably in 15 years, but it was a series of theaters, a black box theater, and then these 2 theaters in a big open plaza, kind of urban design project. So in addition to the idea of these kind of ramps that went out and kind of activated the urban plaza, the concept was really about the relationship between the space of a theater and the space of simulated imagery. So what we did is we took the proscenium of these theaters and we kind of extended the content happening in the theaters into this 2-story walkway. And there were big screens here that kind of activated the plaza. So what was going on in here in real space was actually being simulated kind of in virtual space in the plaza. It's kind of an old idea now, but you know, this is 1992. These are the dates down here, just so you're following kind of where we're at. So that kind of, you know, that kind of stuck with us. The other thing that's kind of funny about this project, this was the last project we did before we shifted to doing everything digitally. And at this point, the second phase, we actually did all the renderings with a software that was just somebody had written the software by hand. It wasn't a packaged software. This was before the earliest software packages. And so the only way we could get output to actually put on our boards was actually photograph the screen. So you could get a render up on the screen, but you couldn't actually print it. So we had our photographer, you know, sitting there with a 4x5 format camera in front of the screen, just waiting for the image to come up so we could take a photograph, print it, and then put it on our boards. So, you know, that was then. So that at the same time, you know, we were doing small interior projects, mostly residential at that time. This is a client that we actually did 2 or 3 projects for. You know, a series of sliding panels that allowed them to kind of reconstruct their loft in different ways. And then more competitions. This was a competition for a library, and again, a library in Japan for their National Diet Library. We didn't do very well. We didn't get shortlisted on this. Actually, wasn't even really too happy with this project. But again, it was just part of the trajectory that we were doing between competitions and built work. Then, about this time, this was 95, we got a commission to do a very interesting project for Cooper Union in New York for their engineering school. It was in mechanical engineering. They had just bought computers as a teaching tool. And the chair of mechanical engineering, a great guy that we became very good friends with, was just trying to figure out how to teach with technology, how to teach with computers, and what it meant for the classroom. And so we worked very carefully with him, not only on the design of the project, but actually on the design of a kind of pedagogical approach to how to use computers to teach. This is where it starts to look very dated. Some of you will notice these big SGI machines that were powerhouses at that time. But what we did with this project was there was like a strong programmatic component, and that we developed this concept in this project that we still kind of use. And it was basically just thinking that in a teaching environment with technology, you can teach and you can learn at multiple scales. It's no longer just like you with your work or you with the teacher, but you have this capability of working alone as an individual, working in a cluster. We designed all the furniture in this project too. Working as a group. This is rear projection presentation room that also you could see these images out in here. Well, the one that really was interesting to us was this idea of multiple scales. And this, again, it's second nature now, but at the time it wasn't. That you're literally, with technology, you're learning and thinking at multiple scales all the time, just seamlessly kind of zooming in and out of information and content and knowledge. And so we were trying to come up with a spatial concept that captured that. And we still use this today in some of our work. And then I think, does that say distance learning down there? That's an old term. But at that time, it was pretty cool to be able to log into a remote location. Architecturally, we had just become very interested in CNC fabrication. So we were kind of using these projects to explore and kind of push industry too. Again, even in a small project. So we designed this kind of sinuous ceiling. We used the same geometry to design the furniture, so these lines actually follow the lines of the ceiling. Used CNC technology to mill all the templates for the ceiling and all the furniture. And at this time, I think the fabricator we ended up working for had bought a CNC machine, had no idea how to use it, so somebody in our office had to go and teach them had to learn themselves, but then teach them how to actually use this machine. So it was definitely, it's actually been something we've done a lot of. We get into projects and we use projects to kind of push our profession and push industry forward. We're always looking to do things that haven't been done, even if it's at a small scale, and looking for ways to kind of improve the processes and methodologies with how we work. So just some other images of this. A little bit later, we got a commission at Columbia. This was a simple but very formative project for us too. The mandate here was for their School of International and Public Affairs. And they had a theater. It was basically looked like this. And it was used for big events. And they wanted to transform it into a teaching environment where, I forget the seats, I think they were like 320 or 330 seats. So they wanted to reconceive it as a space that could be used for classroom use in a way that a teacher and a professor could walk around without being mic'd and that everybody could hear them. So it was more informal. It gave you a chance to kind of wander and not be tethered to a podium. So it became a project about acoustics. So we teamed up with, with Arup Acoustics, who at that time, it was a very small group in New York. Now they're one of the most respected acoustic consultants in the world. But this was really when they were just getting going. And they did some acoustic modeling for us. And basically, intuitively you would know this, but just came up with this idea that if this is the stage and somebody's up here presenting, the sound needs to reflect to the back but be absorbed in the front so you don't get a kind of an unequal distribution of sound. So essentially it was taking the distance from the front to the back and acoustically trying to even it out. So the acoustic level was the same from the front of the space to the back of the space. So it led to something like this. The stage is on the left side and the rear of the theater is on the right side, or the classroom is on the right side. which is basically just a surface that is more reflective at the front, more absorptive in the back, and it gradiates from the front to the back. So the sound absorbs more in the back, but reflects from the front to get to the back. We also, the other thing I'll say about this is that this was not scripted. This was one of the first perforated projects we did, and we laid all this out by hand. Probably in Illustrator, but it was not generated. We weren't doing generative algorithmic, sort of design at this point, and so it's very tedious. A very early version of a CNC machine cutting all the panels. Again, the client, I think the client was about ready to kill us at this point because they wanted to see this product in a catalog. Show me a sample of this. Where can you show me in Sweet's catalog where you can get this? I said, well, if you want this room to function like you want it to function, there is no standard product that allows you to do this. Concepts of customization were starting to occur at this point, and so we were able to convince them that new technology was allowing you to kind of customize the use and performance of a space way beyond any standardized product. And these are the kind of discussions that we constantly have with clients, really in an effort just to continue to push things forward. A few years later, we were fortunate enough to be commissioned by the Museum of Modern Art, the old building, to redesign their lobby and ticket booths. And this was a fun project, very quick project, but it was a project that it was very demanding. I mean, these were the ticket booths that we designed. They had to be rolled out of the way for big events, so they had to be very kind of strong and robust, almost built like a car. So we kind of designed it like a car with a kind of chassis and a shell. And the other thing that was happening at this time, again, as I'm reflecting back, is that we started to establish really strong relationships with fabricators. With these small projects, we were able to literally work directly with a lot of subcontractors and fabricators and establish a really direct relationship. Much harder to do on bigger projects, but a model which I think is still something we need to move toward as an industry. And I'll get into that a little bit more later. I'm not sure we're doing that, but we were able to set up a kind of pattern of workflow in our office that allowed us to do that we just assumed when we scaled up that we were going to be able to do it, and we actually tried to do it. Another residential project that we did, this was for a client that had a 2-story townhouse on an upper floor. They bought the floor below, so we had to open up the floor, make a connection. So, it was just about blowing out a big hole in the floor, putting in a glass floor, and then creating a stairway that connected all the different levels. Again, a lot of great work with, in this case, a steel fabricator that we still work with. We're doing a project with them right now. And what was this? This was 1998. This is just a lower level where this client was actually extremely demanding. They wanted the space to be so flexible that they could work there, they could have people stay there. There was privacy, but openness. They wanted a lot of conflicting, had a lot of conflicting demands, which made it very interesting architecturally. So, we developed this very large horizontal shade that could close off the glass floor to give privacy, but open up if you wanted to, to kind of connect all the floors. So that's it. On the right-hand side, it's open. On the left-hand side, it's closed. Another project about the same time. In this one, it was a top floor loft, small space in Soho, and we cut out a slot in the ceiling to open it up to the sky because it was a top level unit, put in a mezzanine. So this was just an empty box when we started. But this one, was just an exploration of materials, light, and just the quality of space. So that's it open. So this entire back area, which is all the private zone of the house, can either open up or close down. This is a detail of the sliding glass panels. I mean, just an example. You can't see this, but the hardware. I mean, we were just like into finding unusual products. So the way this thing, these are huge glass panels. The way they slide is on a rolling system that is actually, it's used in warehouses to move huge pallets around warehouses. So we got the smallest version they had and retrofitted it for these panels because we didn't want any hanging hardware up here. We wanted just this really clean piece of glass sliding into this track. So we wanted to kind of invert the hardware to hide it. So those kind of explorations, were part of what we were doing in the kind of early days. So then in 2000, another competition we entered as an open entrance, and this one we actually won. So we thought, okay, well this can happen. You can do this. It was for a school in Chicago. It was a very interesting project because it involved not only just a project, but the city of Chicago and a lot of cities at that time were looking at ways to reconceive urban education. The model up to this point had been a kind of industrial model of education where you put 5,000 kids in a big building and teach them all the same thing. So theories of education were transforming to where there was much more emphasis on one-on-one, much more emphasis on learning than teaching. And so the school systems were trying to figure out a way to economically, in a feasible way, break down big schools into small schools. So the idea here was very simple. In this case, it wasn't that big. It was 800 student elementary school that had to be broken down into 200 student modules that shared some facilities but had some independence. So it was about this balancing and negotiation between shared space and independent space. So as you can imagine, these are the schools. This axis along here is where all the kind of common shared space is, the library, the gym, things like that. We also had a very strong relationship to the landscape here, where the landscape kind of just subtly dipped down and entered the building. So the building was 2 levels, but it was done in such a way that there were no ramps and no stairs because the transitions were all what's called landscape. It was also based on universal design. Universal design was kind of new at this point, so they wanted to also use that concept in the design where there's not a distinction between those that have needs and those that don't. And it led to a pretty interesting design result, I think. So this just shows, a kind of diagram. We were doing a lot of research on education theories at that point. We also had a son. I should say my partner is my wife, for those of you who don't know that. And we also had a son that was just entering elementary school at this time, so we were really into understanding what education was about. So we did a lot of research on just theories of education. And there's this term that's used, some of you might know this, constructivism. We think about that in a different way in architecture, but it's basically a theory of education which says that knowledge is constructed, not conveyed. In other words, you have to learn how to teach to where you can allow students to construct their own understanding of concepts and ideas. You can't just convey it out. So that was very interesting to us, and it kind of influenced the design diagram. This was also supposed to be a prototype. So we were thinking about how this one building could be replicated around the city and kind of react to different occupancy needs and different site needs. So it was kind of an early, I would say an early concept of parametric programming, where you have certain anchors. We called these bootstraps at the time, where there were anchor points where these schools would link together. So these were fixed. But the size and the configuration of the U's, of the rings, could expand, could deflect to avoid a tree, avoid a site condition, could get bigger for bigger schools, could get smaller for smaller schools. So you maintain this kind of, I would say the basic concept of the diagram stayed in place, but it could adapt to different site and program conditions. And then this is just the final model with some sections and details. There was a ramping system, technically called the landscape, which kind of wrapped around the U part of the building that fed into all the classrooms. So the classrooms were located around these things, and then the ramp was on the inside. Each school had an internal courtyard, which is here, and also an exterior courtyard there. So there were a lot of overlapping shared spaces between schools, but also a lot of privacy within any one school. Paul, can you see if my water's down there?
It's actually right here.
Oh, sorry, excuse me for a second. So the other thing we did with this project, and this was kind of one of the efforts that we did to win this thing, was to explain the concept to lay people. And so we came up with this idea called time use diagrams, which was basically trying to explain in it was a very complex situation in terms of users, because you had students that belonged to each school, you had teachers that were shared between schools. So we developed this representational technique where we would basically, through scenarios, lay out something that might happen. at a given time over the course of a day, and we would diagram it by color coding user groups so that a layperson wasn't just looking at an abstract plan, not having any idea how it would be occupied. They would actually be able to put themselves in there, identify themselves with one of the symbols used in the diagram, and begin to understand how they would interact with each other and how the complexity that we were arguing for in terms of program could be viable and conceivable over the course of a day. I mean, it was essentially inspired by scenario planning. It's a very long story. It didn't get built. It was very frustrating. This is where I'm going to start going off on a tangent, but we were about to sign the contract. It didn't happen for a number of reasons, and that was a tough one. So we continued to do small projects. This was a restaurant we did where we took some of the techniques that we had used in the auditorium for acoustics and developed this ceiling panel, a custom metal ceiling panel that again had different acoustic zones to have dining areas that were louder and dining areas that were more quiet. Again, this was still being laid out in Illustrator, this stuff. It was really maniacal. Early versions of just, where the architect would actually take responsibility for the production of the panels. I mean, our liability insurance agent had no idea what we were doing because they would have literally dropped us. But again, these are just one of those things you have to do if you're going to push things forward. If you let insurance companies dictate the progress of our industry, we're not going to go anywhere. So as a small firm, we can take risk. These are some of the panels, individual panels that made up the ceiling. Another residential project we did, this was for a client that had a really interesting collection of folk art. So in this one, it was really about a kind of material research and trying to develop a context that would fit the art well. So we used a lot of different materials in here. We did a cast-in-place concrete kitchen. Interesting, in New York, you really can't do cast-in-place concrete for an exterior finish until recently because of the concrete industry. It's a long story, but this is the kind of politics of working in a place like New York City, where people that would try to do high-end concrete like this in the city would be discouraged from doing so. So we did it inside. This was blackened steel, translucent glass with shelves on the back. You get a kind of silhouette through the glass. Again, it was all about kind of relating to the art. Another competition, I'm going through these very quickly, and I'm going to spend more time on a couple of projects at the end, so don't worry, I'm not going to be doing this the whole time. Another competition, this was in '02, that we got invited to in a long list, like 24 people. We got shortlisted down to 3, but didn't win. It was a project for the Fashion Institute of Technology. And I think the unique challenge of this building was that the site was only like 40 feet wide. It was very challenging. It was for classrooms and academic space. It had to connect to a big building, which you can kind of see over here, but the building itself had to be kind of independent, and you still had to allow enough light and air in between that building and this one. So it's a very constraining site, 200 feet long, 40 feet wide, single-loaded corridors. So our concept was really about how to kind of understand the building, the entire building as a facade, and make it a kind of weave between the city and the campus, which was on the other side of this building. So this is just an early diagram we did for that. Some images are dropping out here. That's not good. All right, bear with me for a second. Uh-oh. Okay, that means that I need to hurry up, I guess. Okay, I think the last one of these projects was a project that we did in '03, and this was the first time that we started getting involved with the city of New York. And At this time, Governor's Island, which was an island just off of Lower Manhattan, which had been unused for many years, the city was starting to think about what to do with that space. And we were asked just to come up with one idea for a type of use. It's a very quick project, just really kind of a sketch idea. And we proposed this idea of an ecological learning center. And it was, again, it wasn't a fully developed project, but it was just supposed to be something that would get people excited, get developers excited about what to do on the island. And Governor's Island has actually started to evolve, and some interesting things are happening now, which we're not part of. But I think what was important for us about this project was just our engagement with the city, which continues to this day. It's really bogging down here. Just another image of that. Okay, so now I'm going to shift. That's the kind of fast pace through the early years. At that point, we had started to develop a kind of idea about what practice was, what industry was, what was going on with industry, what was possible with industry. And we developed, I don't know if these are theories as much as they're just kind of working concepts. But these kind of fed over into the book that I did most recently. And there were three kind of conclusions that we came to in terms of what was going on in the profession of architecture and more largely in industry. So there were three things that we started thinking about. Designing design. And this was just simply a realization that at this point, design processes, as we thought about them, were changing radically. And that you could no longer take for granted that the process that you engaged in as an architect was completely compatible with what you really wanted to do. And so the idea was that design systems were being designed by software companies and others. And architects needed to understand that design itself was a design problem. And that's how we started to think about our work, that literally design is a design problem. It's a meta problem that with technology has enormous potential, but also has consequences, that if we don't engage in this evolution of technology and its relationship to design, you know, our voice is not going to be heard as a profession. The second one was designing assembly, and this was related to digital fabrication, but more importantly, it was thinking about the possibility that you could, now that architects had a direct link to fabricators through CNC technologies. In other words, you no longer really had to do drawings that then got handed to somebody that then somebody interpreted and built. You could literally go straight to manufacturing. Profound implications, in my opinion, not realized at all. So designing assembly was the idea that wasn't just digital fabrication. It was the idea that you could literally, as an architect, design the assembly processes that would be used to put your buildings together. And then the last one, designing industry, zooms out even more and really talks about organization. That, again, through technology, that industry was shuffling quite radically, and that, again, industry had to be thought about as a design problem, that as an architect, you could intervene and start to set up different relationships with partners as a way to set new protocols and standards for industry. So if you think about that from an engineering side or a process management side, you have one attitude about that. But if you approach it from an architect side, you have a completely different attitude about what industry should be. And so the argument here was that, and for us, that we had to be involved in that reorganization of industry. We couldn't just say it's going to happen and we'll just plug into it. And the only way really to get architects interested in that is to pose it as a design problem. Not a technical logistics problem, but actually as a design problem. So this is a project that we did for Columbia University. Very, very small project, but very important for us. It's for a slide library for the Department of Art History and Archaeology. And this is what I want to focus on here. I'll talk about the design, but it was a design of the organization that we did. At this time, this kind of merges with my teaching. I had just become director of the fabrication lab at Columbia. Barry Bergdahl had just become the chair of art history. We had this small project in the Department of Art History from our practice with Columbia. So as a professor, I was directing a fabrication lab. I was a vendor to Columbia facilities, and I had the mandate with the fabrication lab to do full-scale stuff. No models, full scale. So we thought, all right, let's put all these pieces together. In other words, let's design the organization of the project and see if it works. So we came up with this idea coming up with a design for the project, using Columbia students and Columbia architecture facilities to fabricate the thing. We had a contract with Columbia Facilities. The School of Architecture had a contract with the Department of Art History. So it was this interesting kind of legal setup that everybody bought into because we presented it as a win-win thing. It was good for everybody. Very simple project. It was just literally a box. Of course, we made it as complicated as you could possibly make a box. And it had no light. When we first got there was no light. But we crawled up in the ceiling. We were doing some probing in the early stages, and we discovered this thing. This is the top of an old McKim Mead and White building in the attic at Columbia. So we discovered this thing, and it was a huge skylight that had been covered up, and it was right over this space. So and that's it right there, kind of dashed in. So that changed the whole thing for us, because we thought it was just going to be a real simple, no light, very challenging in terms of quality of space. But when we discovered that skylight, it changed everything. So basically, it became a very intense fabrication project. We treated it like a piece of furniture where all the pieces were fabricated and put together as part of a kit almost. And there was this very didactic concept that we had, which is kind of demonstrated in this diagram, which is that this wall was, let's say, the wall that we put a lot of emphasis on in terms of design. These other three walls were really just, think of them as kind of screen walls to the space. But what we did is that we took this was made up of this series of layers of MDF, like what we have over in our atrium, very common at this time. So we took the tooling paths that we had generated to construct this wall, which are up here, and we repurposed them and reconstructed them, really repurposed them as perforation lines for these other three walls. Right? So the same data that's being used to construct this is being used to generate these perforations around the other three sides. So it's kind of a reuse of design information that became a design concept. Does that make sense? We worked really hard with this diagram to try to explain this. But this is what was used to actually cut the panels out for this wall. And then these are, these panels where these tooling paths have been compressed. This just shows just kind of a transformation from a wireframe design to a rendered model to the final design. We did a lot of prototyping. We prototyped everything at full scale before we built it. Fabricated everything in the shop. When we didn't have much capacity at that time, so when we would reach our capacity but had a deadline, we would outsource some of the work. So that was also part of it. How do you use facilities and create a network of fabricators to create something? We were maniacal about the mandate that every single piece in this thing had to be modeled and milled and put together. So no table saws, even though it would have been a lot easier to cut these things on a table saw. We wanted to exercise or kind of explore this idea that you could literally model every piece, send it to a CNC machine, fabricate it, and put it together. So these are the pieces that make up these kind of columns that make up the walls. That long wall was held together by compression. They're just threaded rods that feed all the way through it and just hold it together. So there's no glue or no. This is the students assembling it over the summer. The whole thing was done in about 2 or 3 weeks, and this is the final result. Still there. When was this done? 2004, still there, still looks like this. It's a great thing to even take students over and see right now. I don't know if you can see this, but you see the kind of imperfections here? The client really loved that. I mean, this is art history. The client loved the imperfections. It's like how you have this hyper-precise process and hyper-precise equipment, but you still have this kind of this texture of the process, that it doesn't get eliminated. So we also like that. I mean, we love the idea that there were the kind of, not really flaws, but they're just a trace of the process that still shows up. You can't optimize that out, nor do you necessarily want to. So here you can see kind of detail of those tooling paths that have become a kind of what I call a perforation line. And then on the inside of the space, this is the effect you get. And yes, there are still slides in the old wood cabinets, which are quite nice. And then just some details. So when we did this, we set it up in a way that we were really thinking of it as a prototypical process that could be replicated at schools of architecture around the country. So, you know, we're going to try it here at some point, hopefully. But the idea is that universities have enormous capital resources and they build projects on campus. Schools of architecture have very eager and talented students that want to do stuff. You can probably get a lot better value from the School of Architecture than you can from the market. So why not put all these ingredients together? It's a great learning experience. It's a great story for the universities. It's a great experience for the students. And so we were really kind of, we were designing the project, but we were also, again, designing the process in a way that we could potentially replicate it. The next project, this was a bit of an anomaly for us. We don't do a lot of installations, but we were commissioned by the Museum of Modern Art to participate in an exhibition they had, Home Delivery, Fabricating the Modern Dwelling. And this was the first exhibition that Barry Bergdahl did when he became curator of MoMA, and he was our client for the slide library that I just showed, so that was pretty convenient. So he had this very ambitious idea for this show, which was that he wanted to show a kind of history of prefabrication in architecture, show what's happening today, and then also show what the future, where we were headed in terms of the integration of fabrication and architecture. So I don't know if any of you know the show, but Barry commissioned 5 teams to build houses, essentially, out in a parking lot next to MoMA. It was incredibly ambitious, full-scale houses. He commissioned 3 architects to do just small installations inside, and we were one of those groups. So the houses outside were supposed to be, this is the cutting edge of what's happening now. The kind of installations inside were supposed to be about speculating about the future. So we took this idea of designing assembly that I just talked about, and we said this is a good kind of test case to push that to a limit. So we were very constrained in terms of size. You know, it had to be kind of a wall. So we had this idea of simply taking 2 pieces of steel plate, and figuring out how to create a structurally robust wall without any fasteners. Okay, no fasteners. And also be, you know, kind of beautiful, aesthetically interesting. So we started by doing paper models that you see here, kind of just studying patterns more than anything. But it became clear that we had to start working with the material to really get to this structural idea. So this is a little kind of concept statement that we developed, where we were comparing and trying to differentiate where we are today in terms of thinking about details in architecture with the modernist concept of detail. So we were kind of proposing that modernist details were about managing pre-manufactured parts. So if you have part A and part B, you put it together with a C, with a third part, right? So what we were proposing is that with this ability to link directly to manufacturing, that the assembly process itself could be actually embedded in the logic of A and B. You did not need the third piece to actually put 2 pieces together, right? So the assembly was embedded in the design. And that becomes, you know, a step toward full integration. So these were some of we did a lot of tests to try to get, you know, pieces to this was in steel. This was actually in the material. We were working in the material that we were going to do the final version in, studying just different pattern types, different tab types. And it was a lot more complicated than we thought to get something to be structurally stable. So we really started focusing on the tab itself. Literally, the tab was what folded from one piece and another piece to lock together to make this structurally sound. So we did a lot of studies to get work. And finally, it was kind of obvious, but we realized you couldn't do tabs like this. They had to come at each other at 90 degrees to be structurally stable. You know, it's kind of obvious, but it took us 15 of these samples to figure that out. So it was all about developing this tab topology that would then get instantiated to make this entire panel. So this kind of goes on for too long, but this is just the diagram. Well, it's more than a diagram. It literally is the kind of tooling paths for the tooling path for one tab, one set of tabs. We had to name all the different parts. I mean, this is at a micro scale. To scale, this is only about this big. But we had to be extremely precise here. So I'm going to go on here. I'm going to go on for too long. So that just continues to kind of, those are the 2 tabs. The tabs, there was a major tab, which was this one, and a minor tab. So that tab snapped together with the tab on the other side, and this one did the same thing, but it snapped together with the minor tab on the opposite side. This might explain it more. So this was the essence of the entire project, was this little detail. And this shows you in a more 3D view how it worked. So that's the minor tab coming along to lock into the major tab. And this was incredibly strong. So then we just developed, we actually had to do this in CATIA. It was a very complicated model to do because the tolerance for these tabs coming together there was no room for mess up. So there was literally a point in space that we had to meet with these tabs for each one of these. So the variation in the pattern that you see on the surface is a result of the distance between the two panels. So this was also, we were very interested at this point in trying to merge form and fabrication, let's say. In other words, there was a lot of work going on with algorithmic design at this point where it was very driven by form as a kind of dominant driver. We were trying to figure out a way that you could merge kind of formal and aesthetic aspirations with assembly aspirations where one was the result of the other. So the pattern, the actual design that you see here, is literally a result of the logic of the mechanics of it coming together. There's no preconceived form here. And essentially, one of the other participants, this is Reiser Umemoto, who are amazing architects. This was their version. And what was interesting about this one, we're all very good friends, but they were literally creating this in their garage with rubber mallets trying to bend this thing together into a shape to get it to look like this. So they're very driven by aesthetics, unapologetically. And then the other entry, I don't have better images, the other entry was from Ali Rahim, and this one was more about 3D printing blocks and just kind of sticking them together. So I think it was a very interesting three approaches to the idea of the sort of future of technology and architecture. And here's just some shots of the final installation. Okay, I'll try to go through this quickly, and I'm just going to focus on one aspect of this project. This was a project also we did at Columbia. Columbia's been very good to me, actually. This was for the School of Journalism, the Graduate School of Journalism, for a student center, a kind of social hub. We had done a master plan for the entire building and did a couple of projects, but this project was very small, actually. It was a small addition and interior renovation. Kind of, the addition was lodged in between two buildings, and the addition was adjacent to that. So the addition was literally just a roof and a front facade, because the two sides were the sides of the existing building. Okay, so this is what we did with this project. We said, okay, in a typical project, you have your standard consultants, your vertically integrated consultants, right? Your structural engineer, mechanical engineer, these are contractors, a fabricator. This was another contractor because that contractor got fired. So you had this, this vertical alignment that make up a team. What we were interested in was, and I've actually teach a lot about this, is the concept of a network practice. Okay, how could a small practice like ours expand and kind of grow horizontally to bring in expertise into our office that we didn't have and we couldn't afford, but that we could kind of coalesce and assemble for a project, for a particular project. So what we did is that we teamed up with all the, Front. Front was kind of more of a standard consultant, but in this role they served as a more unconventional consultant. These guys were 2 years out of Columbia, recent grads that were very good at scripting. This was a graphic designer that was quite good. The Stevens Institute of Technology, fascinating program where their students actually work with firms and work on real projects. So we had those students in our office. They have incredible skills. We had them in our office, and they designed and were responsible for a part of this project. So this was a design team, right? We're just one member within the design team. So with that, what we did is we kind of set up the design in a way that there were 4 parts that we would kind of work, that we would give to each one of these design teams. And they all had to do with the kind of performance. Acoustic performance, cultural, was kind of the graphic designer, environmental, which is really more solar, and dynamic, you'll see in a minute what that was. So the first one, we were working with the group from Columbia, Proxy, acoustic. So we had to address an acoustic problem in the space, and that this was going to be a very loud space, a lot of people, and we had to create an acoustic ceiling. You know, we could go spec an Armstrong ceiling, it would be very ugly, or we could do something and kind of explore a design process to where there was a file to fabrication process. So they developed, this is all their work, they did an acoustic model, they developed a script based on attractor points. That was a design objective, not necessarily an acoustic performance objective, but we were combining aesthetic concerns with technical concerns. They generated hundreds of options that all met the acoustic criteria, so it became an aesthetic decision, not an optimization decision. And then this was the result. So that was that surface. This one was more interesting because there wasn't a technical performance. It was just, there was an idea that we wanted to have some kind of graphic that talked about culture. It's very vague, and I apologize for that, but I don't want to get carried away here. So what we did is that we took the building across the street from this site, took a photograph of it, pixelated it, and mapped it onto the surface, so that when you look out the window, the kind of pixelated version of the facade merges with the space across the street. And we had a number of discussions with the faculty about what this meant. And I don't know that we ever determined exactly what it meant, but it did mark a kind of place in time. And it had a beautiful effect, actually, because the resolution of the image was in such a way that when you approached it and you were like 40 feet away, you could see it. And as you got closer and closer, it kind of abstracted because the resolution was not that high. So it had this really kind of engaging effect in terms of things coming in and out of focus. It was hilarious when it was being built. You know, the contractors were just like, what is going on here? And after they got the whole thing up, I'll never forget, I was there with a sub that had to install this, which was not easy to install, this very heavy gauge steel. He kind of stood back about 30 feet away and just looked, oh, I get it, you know, and it was just like a moment, it was all worth it for this guy once he kind of just clicked into his head. Okay, the third surface, environmental performance, it was really more about a sun study. This was in the little addition, which was a cafe. We did a glass roof and then put a sun shade on the underside of that. So this is with the Stevens students. These are students doing this. They did, you know, a kind of a solar analysis model. They generated a script based on, because we wanted to do a corrugated surface. That was a design decision. They then generated a script based on these rules that allowed them to build a tool, very simple RhinoScript tool, for us then to play around with and study different design options. So we defined the design space with them, but the design space was open enough that we could actually explore different iterations of different options. And so this is the one that we ended up going with, but we looked at many of these before we finally decided on this one. And again, you can look at this and say it's very limiting, but we had already made a decision to limit the design space to these parameters. That's the final version. Now, that generated the corrugation of the surface. Now we had to do the perforations. And so for the perforations, we had this idea that we wanted to have the effect of kind of being under a canopy of trees, a kind of flickering light effect. So we took a photograph of just in the space looking straight up at clouds. They developed a script that would just read the pattern and the density of the clouds and come up with a perforation pattern for each panel. And then those things were, you know, what you just saw was just one of these panels. And so this was just the kind of modularization of the panel so you could fabricate it. This is the unfolded surface. And so this is what the result is. You never get any direct sunlight. It's all indirect reflected light, and it's actually quite beautiful. And that's the space. And then the last surface we called dynamic or mechanical surface. We wanted the front part of this facade to open up to the campus. So this was actually Mark Simmons doing. He knew this amazing mechanical engineer in Argentina who is known for building like dynamic parts of buildings. So he only gets involved in a project if it's moving. This was a small project for him, but he was really into it. So he basically built a huge double hung window we claim it's the largest double-hung window in New York City. But it's basically, this is the frame being tested in his shop before it came to site. It's about 20, I think it's 22 feet wide, and about each frame is about 10 feet tall. So he had this thing, he built all the mechanics, he built all the parts, the standard parts, put them all together, did the screw jack, the motor, and he had it going up and down in his shop for, you know, that's my phone, that's weird. That is weird. I have that happen all the time. Just got to make sure the phone isn't on now. Okay.
It's going to restart, so it might be a minute.
Oh, so it literally, okay.
Just shut down.
All right. I'm going on, I'm not where I should be. It's 7 o'clock. I have one more project to show. So I think we'll be okay. I'll quickly go through it. But I think what you'll see what I'm trying to show here is that, you know, at the same time that we're designing projects and satisfying briefs for clients, you know, with each project, we look for an opportunity to also kind of do what we would call research, whether it's research into changing working processes or research into manufacturing processes. We always try to roll that into a project because you may or may not know, you know, the fees that architects get can't sustain true research. We don't get enough fees to do that. So the only way that we find to do that is to literally find some place in each project to execute that research so that we can actually pay for it through the fees. I could tell Aggie jokes.
It should just be a second. I think it should come on.
Okay. The last project, I'll just start describing it so I can go through it more quickly. It's the library, the Glen Oaks Library, which was one of our more recent projects. And there were, we got the commission as part of the New York City Design Excellence Program. They had just started this, and this was the first commission from that program. So it was a great project for us to do, and it had a mandate of design. It happened, it started, and then 2008 happened, and so everything went on hold. When it went on hold, we kind of went into R&D mode because there was literally nothing going on. So all we could do to keep our staff going was just to kind of, you know, continue to work on things. So what we did with the project is that it was the last project that we had done in AutoCAD. And so we decided, okay, and at that point, we had already switched over to Revit and 3D at that point. And so we said, okay, let's take our drawings that we produced in AutoCAD and let's build a Revit model of it, which is actually what contractors do with all of our drawings right now. And so we did this as a kind of exercise and built a super detailed model. I mean, more detailed than you would ever do, you know, if you didn't have anything else to do. But we discovered a lot of mistakes in the 2D drawings, which we solved. But more importantly, we were trying to use that model as a way to allow the project to be built to a higher quality. And there's a little context here which is important. In New York City, for public work, they have this crazy law called Wick's Law. Now, Wick's Law developed many years ago, and it was developed to prevent corruption in the construction industry. But what it means is that on public projects, when they go out to bid, they don't go out to bid to a general contractor. They go out to bid to 4 separate prime contractors. So they'll send the drawings to a general contractor to do the architecture and structure. They'll send it to a mechanical contractor, an electrical contractor, and a plumbing contractor. And they sign independent contracts with those people, and they don't even know each other. So you can imagine what a disaster this is. The people that are building the project don't even know each other, and they're supposed to, you know, be working. I'm going to quickly go through this because you've got to see the door opening. So there's the door opening. It takes 4 minutes and 38 seconds for it to open. It's kind of cool. They do it every day. It's going up and down every day. It's been, I guess, 6 years now. That's the effect inside where you have this relationship to the campus. This was a kind of scary moment when I came to school one day and walked around the corner and looked over and I thought they took the building down. So this is the library, and I'll go through this quickly. I've given you some context. It was in Queens, on the outskirts of Queens. This is Manhattan, so it's about as far out of New York City as you can get. This is challenging. The program called for twice the amount of square footage that the site allowed. So the only way that we could solve that was to put half the square footage below ground, which doesn't count toward the allowable FAR, which was a big design challenge. Like, how do you make a nice reading room below ground? But it actually ended up being, again, one of these real constraints that becomes a very interesting design driver. So this is, a quick section of what we ended up doing. The main reading room is below ground. And then, so half the square footage is above ground, half the square footage is below ground. 3 different reading rooms. The users were children, young adults, and adults. So the children go upstairs, the young adults go back in this area, and then the adult reading room, which is the main reading room, goes downstairs to the lower level. And then that's the rendering. October happens. Here's the situation. You've got 4 different contractors that are going to build your building that have never even met, which is not the way we had worked. So we thought BIM was going to save the day. And it actually did help a lot. So we ended up modeling everything. We modeled the mechanical, the structure, the plumbing. We modeled everything. And more than anything, it became very useful on site just for simple communication. In other words, we were able to, and we actually worked with the general contractor. None of the contractors had even heard of BIM. But we worked with the general contractor, showed them what it was, asked them what would be useful for them, what would make their job easier in dealing with these people that they didn't know. And this has actually led to this thing. They told us that we need to be able to go into the model and identify specific parts through tags so that we can then communicate that to our subcontractors. Besides just the 3-dimensional complexity, they wanted us to make every object in there taggable so you could identify what it is, and the spec section. I think we had the spec section. So we added these attributes into the model, and Chuck Eastman is in the audience, and he's probably looking at this thinking that I did fake it a little bit here. For those of you who don't know Chuck, some of the undergrads, Chuck, his work is what makes this happen. So if you don't know him, you should introduce yourself. You should shake his hand. Hell, you should probably give him a hug, because what he's done is develop technologies that are going to make your engagement in practice fundamentally different. So it's very important what he's been doing his entire career. This one was about maintenance. I don't know if you saw it, but we tagged the objects and then linked it to a PDF of the product. So if you needed to change the light bulb, instead of going through an owner's manual that you'd never find, you click on the light, it gives you the PDF and tells you what kind of light bulb to use to change the light. So this is when we were starting to make the pitch about, post-occupancy. So one of the kind of main concepts we had was utilizing this word search. So what we did is a very simple, quick sun analysis of the site. The main part of this is the building right here. The main facade faced north. So through this analysis, and then we came up with this idea of a double parapet. This is the north facade here that faces north. We came up with an idea of a double parapet. So this is an enclosure, that's an enclosure, this is interior space. We put the letters for search on the back of this is like on the parapet side, and then the sun just projects it onto the front facade. No moving parts, no maintenance. Client loved it. Had a lot of discussion about what word to use. Some people thought, you can't believe, I don't know, I can't even get into it. But some people just were not sure about the connotations of search. We thought it was about the new library. You're going from you're not going from reading to searching, but searching is becoming instrumental in our attainment of knowledge. So this is what happens then over the course of the day. In the summertime, the sun is at a higher angle, so the letters stretch. They're longer on the facade. In the winter, they're shorter. When clouds come over, they disappear. It's actually quite an incredible dynamic thing that really engages the public when they walk by the building. I'm not going to play the whole video, but it just disappears over the course of the day. These are just some of the different effects. We hadn't, these are some of the effects inside that we didn't anticipate. Another thing we did was on the lower part of the building, we wanted to use this fact, which we discovered when we were doing the project, that in this very small community of 20,000 people, there are 50 countries speaking 29 languages, pretty diverse. So we had this idea of translating search into all of those different languages and then using that to help generate a frit pattern for the lower curtain wall. So this diagram kind of explains that. It's this lower part of the building. This is just one grouping of panels. This is where the glass occurs, and this is the facade unfolded. So, so this, I don't know how much you can see it there. Besides, the words are printed along here, but there's also this other kind of more abstract pattern that we generated a Grasshopper script to create, which I'll show you. These are all the different languages. Here's just a sampling of them. And then these little guys, this pattern's next to it. This is something, again, where you just go way out there. But we captured the demographic knowledge of the community. We built a Grasshopper script that created these bars, what we refer to as books, the kind of reference books. So from a distance, they look like books on a bookshelf. But each one of these bars represents a language. And the bar that's associated with each language appears in proportion to the amount that language is spoken in the community. So again, it was just data that we used to drive a design approach that allowed us to create the pattern. This is just a family, looking for their native language with their young kid. It's very engaging to the community. So this was the script that we developed to generate the pattern. So this is the pattern, and these were the parameters, the design parameters, where we could play around with really just different compositions. But no matter what pattern shows up here, it all follows the rules of the demographics. It never violates the rules of the demographics. We had a lot of different ways in which you could vary it and shuffle it. Again, this is what I mean by designing design. I mean, it's kind of obvious, but the decisions that one makes when you're working with a parametric system like this determines, obviously, what you're going to get here. So you're defining a design space here. You're designing design when you do this. And it's enormously liberating. Some more shots. And these are some shots of the underground space. So that it's a pretty nice basement. There's a big, we brought light down in a number of ways. There's a big atrium with a stair that goes up that brings light in. There's a long skylight along the sidewalk, along the entry that kind of rakes light along that wall. This is actually that skylight on the sidewalk. This is the main entrance. So when people are walking in, you get this effect underneath. And this is just a quick, iPhone video we did of what happens when you're there. Okay, I'm not going to present this project because I think we need to leave some time for the discussion, but I do want to just say a couple of words about this because this is where we're going. This is a project, our most recent project, and I'm just going to go through this very quickly. But in a nutshell, this is what we were trying to do. We were hired, this was a grant that we got to study the New York City Public Library system. I forget how many, there's like 63 branch libraries in New York City, an enormous physical and cultural infrastructure that's all over the city. The city has no idea what to do with it. They don't take advantage of it. So we were kind of commissioned to come up with ways that they could start to think about this asset, this urban infrastructure asset, as something that's much more useful to the city. Right now, they think about branch libraries as individual pieces. They'll work on one, but they won't understand its relationship to the one right next to it. So we did this project with a kind of data scientist and somebody in real estate to look at the library system at the scale of the city through data, at the scale of the neighborhood through zoning, at the scale of the building through users, okay? These were some of the data sets that we had to work with in analyzing the city and the libraries within the city. Again, I'm going to go through this quickly, but maybe I'll give another talk on this sometime because I think it's interesting. And these were just some of the data. These were some of the categories that we were able to understand how, this is the entire city. Again, all the libraries are identified, and then they're analyzed through visitor counts against population density, right? So it's comparative and relational. Community diversity, user groups. This is for seniors, like senior use. Available FAR by lot. Part of what we were mandated with in this was to figure out how to use the library, most of which have a lot of unused FAR, a lot of unused buildable space. The city can't afford to take care of the libraries. The mayor had a mandate of affordable housing. So we were trying to come up with strategies that would make it appealing to developers to build on these sites. They would have to provide the space for the libraries. They would be able to do housing. It would have to be affordable, which would accomplish the mayor's mandate, but they would also help pay for the library, which would solve the problem of capital upkeep. So that was a larger kind of plan that we were working with. I'm just going to go through this quickly. This is when we moved to the zoning. There were tools developed for each one of these kind of scales. We looked at many different sites, looked at the zoning envelope, but then came up with ways to rethink zoning and make a pitch to the city that you should increase the zoning on these sites if you want to be able to take care of your libraries because you can get more value out of the sites. I mean, zoning variances are done all the time in New York. But we were arguing they need to be done in the public interest. Then we honed in on one site at Brighton Beach and then just developed a scenario building with the library on the lower level and the affordable housing above. And this was kind of driven through user profiles. In other words, these are in some ways, these are hypothetical users, but they're demographically determined. In other words, they're not totally abstract. This relates back to the time use diagrams that we did back at CPS way back. So what's interesting about this is that we did this as a grant study earlier this year. We just signed a contract this afternoon to do a kind of version of this for Brooklyn Library System. And we've also are just about to be commissioned by Brooklyn Library, the Brooklyn Library System, to actually do this for real so that they can better understand how to utilize and take care of their assets. So it's just, again, it's just, I think as architects, we need to be leading these efforts. We need to be the ones out front. And if we can make compelling cases, even to city agencies, they'll listen. I mean, some of you know that, but so this is my book. Please buy it. My publisher would be very happy if you buy it, so I have to do the plug. There's a lot of great case studies in here. And I'm going to end with this image, and this is an image I've shown many times. You'll see that it goes back to 1992, where we began. This is Jim Dlempf. Chuck probably knows who it is, but I don't know if anybody. So Jim Dlempf was in Frank Gehry's office, and he was the one responsible for building this crazy thing and a lot of other things. He was one of the founders of Gehry Technologies. For those of you who don't know, Gehry Technologies was a spin-off of Gehry Architects that was a kind of technical consultant that would allow other architects to utilize the expertise and the workflows that they had developed on their buildings. So this was a kind of pivotal point in that whole evolution. This was for the Barcelona World's Fair, I think. They designed something, they couldn't build it. So this is the first time that Gehry had to go outside the architecture industry to the aerospace industry, bring in their software and workflows into the architecture industry, and they figured out how to build this. It's kind of miraculous, the story behind this thing, because they were like up against a deadline and nobody had any idea how to do this. And they pushed it along, and again, a fish, really? But this is what happens. You have to do these kind of crazy things to push progress. Now, those of you who know, Gehry Technologies then became critical for building hundreds of buildings around the world. They made a huge impact on industry. And at this talk in 1992, Jim ended his lecture by saying that, after his experience with this, by saying that you know, things are changing rapidly in our industry, really rapidly and radically. This is not just incremental change. This is really a major change. And as a profession, architects can either engage or not. But if you don't engage, there are massive builders, there are massive construction companies. They're going to appropriate this technology without the insight and without the point of view of design, of architects. And he made this really convincing plea that even at this point, this is 1992, that we had to engage in this discussion actively and aggressively if we were going to have an impact. And it just kind of stuck with me. And I constantly tell students, like, my generation, forget it. It's not going to happen. But for all the students out there, it's going to be your generation that I think really benefits from all the work that is going on here, all the work that Chuck does. But you've got to take it on. You know, you can't just sit in the back and wait for the processes that are literally structuring the methods by which you work to be designed by somebody else. Okay, that's it. Thank you. Yeah. So those of you, before you leave, we started a new tradition last week that we're going to do this week, where we have volunteers from student volunteers from each of the 4 programs, undergrad, grad, MS, and PhD, that are going to come up and have a discussion with me. So they've kind of volunteered. We did it last week and it worked really well. So those students should come on up, and then we'll have a kind of round table, and then we'll open it up to questions from the audience. Oh, and then there's a gallery opening after that, upstairs.
Do like an asymmetrical thing? Or
Yeah.
just have you all in a...
Yeah, let's do kind of. I'll sit way back so we're. Hey.
I was in a seminar.
Okay.
When you met with everybody.
Okay. Okay, perfect. Yeah. So I have only met maybe 1 or 2 of the students, so I'm going to have you guys introduce yourself and just say which program you're from. Okay.
Hello, my name is Marissa Belmorad. I'm a third-year PhD student.
Hi, I'm Ivana. I'm doing an MS program in high-performance buildings, and this is my 2nd year in the MS.
Oh, you have a mic in there? Yeah.
My name, is this on?
Here, on the side, yeah.
Should be up.
Hi everyone, my name is Gazla Coulter. I'm here at Georgia Tech for the MArch program. Enjoying it.
My name is Colin Garnett, and I'm a 3rd-year undergraduate in the architecture program.
You want to start? Okay. So we always ask the PhD student to kind of moderate.
Thank you. Is this on? Okay. Scott, first of all, thank you very much for your presentation, and also for showing us to the extent to which architecture does not happen in isolation. And I really appreciated the comment you make about architecture as a network of activities. You know, different people, different technologies, at different levels of technology, manifestations of craft, as well as manifestations of digital media. When you said design is a design problem, I immediately wanted to create a new project. So if you permit my analogical jump here, Georgia Tech is a design project. And my question to you then is, how could you bring some of that interdisciplinary approach that you clearly have been developing over your entire career into the working of not only the studios, but the way that design and scholarship also expand in the department?
We don't want to drift too far into the academic side, because this is where, but I will say that, you know, one of the reasons that I came here was that I saw the possibility to actually do meaningful interdisciplinary work across the Institute that was very difficult to do at Columbia, and I find, even talking to colleagues around the country, it's very difficult to do in other places. But here it seemed like that there was a kind of tradition of that and a pattern of doing that, probably more in other schools and other colleges than ours. And so it's definitely probably one of the top things on my list is to start to cultivate that and to bring that into our school. And honestly, and this comes from practice, it will not happen until we establish relationships with these people. And so what I've spent a lot of my time the first 2 months I've been here is just meeting the chairs of all the other departments. And just starting to form a relationship and find ways in which there's common themes that we can start working on or just common interests. And it's been incredibly positive so far, I have to say. I mean, every single chair that I've talked to is just dying to work with architects. So I think it's, and I had a hunch that that's what it was going to be like when I got here. And I think, so there is definitely the desire. And again, I know from practice that it's easy to have desire, but to make it work is a whole different thing. But I think that I've been, and in our discussions, we've been very clear that look, we have to set a structure up for this to happen. It can't just be like, let's want this to happen. We have to literally figure out a way to make it structurally part of our curriculum. So anyway, I'm hoping to bring that. I think my experience both as an academic and a practitioner helps to at least set that up. But also it's going to be you guys. It's going to be the faculty and the students that really make it happen. So.
I mean, there were many things that were very interesting that you mentioned, and maybe I can ask in later questions. But first, I want to start a little bit more general. What do you think, I mean, what's your view on the relationship between research and architecture? And if it's possible to discuss it outside of academic, of course it will always be connected to it, but how come that architecture compared to other fields doesn't appreciate research as other fields? And when we even look for research, we reach out for other fields. How come it's not happening within architecture?
I mean, I think there are a lot of obstacles to doing that. I mean, on the professional side, as I mentioned, it's just difficult to have a business plan around research. It's just very difficult. You know, there are some firms that are doing some very interesting type of research, bigger firms that just allocate part of their profit to actual research, even outside of projects, like true kind of focused research. I mean, I think and this is something I've been thinking about a lot since I've been here, like, because, you know, you go to mechanical engineering, you go to electrical and computer engineering, they're doing research and they're producing things based on that research. So why is it so hard for us to do it? I think part of it is that we're a service-based industry and not a product-based industry. And I think that makes it very difficult. So we either do research around processes, which people are doing that, Chuck's doing that, others, or we can do research around products, and that's another way to go. But what makes me a little nervous about that, and I'm just thinking about this, so it's not a formulated thesis, but what makes me a little concerned about that we have to be careful of is the tendency toward the commoditization of architecture. And I think that this is where I really plea for architects to get involved in the designing industry part. Because if we don't get involved, I mean, it's a lot easier for a contractor just to commoditize the process. I mean, and this is happening in some areas, and that can happen at industrial scales, right? So I think we have to come to terms with that issue, though. You know, like, you know, what do we think about producing and creating reusable, repeatable processes and designs? I think I don't have a position on that. I have both sides, honestly. But I think part of what makes research so difficult is that fundamentally we're a service-based industry, a service-based profession. But it can happen, and we'll figure it out.
Yeah, I'm glad we merged into the research and product thing, because I've noticed that firms such as yours or other ones that I've done research on, it seems like as an architect, eventually you're developing these products, you're designing these products. So for example, the acoustic ceiling that you designed, at what point do you have a product in hand that you can possibly patent and make that a submerge of some sort of a wing of your business as an architect? Because it seems like when you can't find something to satisfy your whole design, the glass sliding doors that you had, you went out and found a factory that made it for industrial. So you go through it, you find it, but sometimes you can't find it. So then you've developed something yourself, such as the ceilings you guys did. So at what point it is just research and development in a service-based business, yet you're designing these awesome products that could actually be packaged and sold. So how is it that we, as a firm, you identify what your responsibility is?
Yeah, I don't know so much if it's a responsibility, it's just good business sense. I mean, you're right. We could have packaged those processes we were developing for perforations back in the mid-90s. Before, I mean, now you can, all those custom ceilings, all that stuff, you can now go, and companies have commoditized that process.
Right.
You know, so companies have taken these kind of explorations that architects do, not just us, and because they're in the business of product, you know, making products out of these things, they've done it, but architects don't really think that way.
Right.
So I don't know. There's even for me, there's something that's still a little bit uncomfortable about that. And part of it might be that, you know, that you run the risk through the automation of everything, you know, which is sort of, everything's being automated now. You run this risk of reducing difference, of reducing the kind of complexity and richness of culture. It's getting a little bit more theoretical now, and I think that one role architects have is to continually reinvent cities, rethink cities. I don't think we want architecture in cities to become a commodity. And it would be very easy to do, but I think in some ways that might be one of our critical roles in this whole discussion of the kind of evolution of technology is to maintain a certain distance and know when to say stop. And know when to kind of, but just saying stop is not going to do anything. We have to somehow convince people that there's value in stopping, because otherwise it will just, the machine will just keep cranking stuff out. I mean, what can be automated will be automated. So, but there are, honestly, I think there are a lot of younger firms, you know, that are doing what you're saying, you know, that are exploring that. Very interesting kind of side story. There's a young startup called, that came out of Columbia, actually. One of them was a student of mine who started this company called Case. It was started as a consultancy to architects. They had extremely strong technical skills around BIM, optimization, simulation, you know, all the things essentially I was talking about. In a matter of like 3 or 4 years, they grew from 4 people to like 50, and I think they ended up being like 70 or 80 people. And then they got bought. They got purchased by WeWork. WeWork, for those of you who don't know, is kind of the Uber of office space. In other words, they lease out acres and acres of office space and then set up temporary hotspot workspace. And they're growing like crazy, right? So this startup bought essentially an architecture startup, and I haven't spoken to him to find out how it's going, but it was an interesting moment for me because in one way they were doing amazing things for the industry. Case was. They were really doing some great work, and now they've been taken away into another industry. And I think we need to think like, why is that? You know, I mean, there was an example of a viable, successful, lucrative startup, and they got grabbed by another industry.
I know the answer.
Yeah.
It's money.
I think it's, is this on?
Yeah.
It's something.
I think it's on. It's on.
Just, yeah, just
Is
speak
it
up.
on? Okay.
Yeah.
Okay. I think it's interesting that this kind of segued to what I wanted to talk about. Is I wanted to jump back to your discussion on like fabrication and like CNC machines, because I found it really interesting, your work on like the fabrication and like the tabs and stuff like that, because obviously what came to mind was our digital fabrication lab and how that ties into our curriculum. But I've also I've had very limited knowledge of certain ideas, but I've seen like a TED talk on this group called WikiHouse, and their whole notion was to that anyone, it empowered the people to become architects themselves. And so the idea was that anyone with a CNC router and some stack of plywood could construct their own house based off these designs that were published on the internet. And so while the CNC router and these tools have the power to completely revolutionize architecture, it also has this kind of anti-architect kind of ideal attached to it. And I was wondering how, like, what your thoughts were on that and how we strike a balance between that, and what's the, what a future would look like if people decide architects aren't necessary. We can do this ourselves.
That's a great question. I don't need the mic, actually. That's a great question. And I think it's a very serious question that we need to think about. I mean, the maker movement is also very much about this. I mean, like, the maker movement is, you know, it's in some ways, it's the democratization of design, where anybody can, actually it's the democratization of production, you know, where you know, several years ago, you had mainframe computers in big rooms, and they became desktops. And so, you know, computing became democratized. Production used to be in big factories, and now they're on a desktop. So it's a similar kind of cycle of this transformation of an industry, and it's very powerful, and it's very, it has enormous potential. The question about, like, are architects necessary anymore when you can download great designs, print them, and have it, is also a great question. But these are the kind of social and economic transformations that are happening. They're happening. This is not hypothetical. That we need to, like, tap into. In other words, we need to own that space, right? And again, we can't just sit around and say, well, maybe I'm not valuable anymore. We need to create a kind of value through these new technologies. We need to be innovating through these new technologies and leveraging all of the potential that other people are seeing and taking advantage of. We need to figure out how to leverage that. And it's going to mean it's difficult because there's this deep culture in architecture of the kind of you know, the singular designer. That's really deeply entrenched in our culture, and it's not what's happening today.
In terms of the transformation of industry, I think that's where I was going with my initial question. To what extent does the transformation of industry already imply a transformation of discipline? And that does affect the academic environment to a certain extent. And it's not just about curriculum, it's about thinking about how architecture might interface in a different manner with other disciplines, not just, you know, those directly related to design. So, I mean, it is a very interesting question, and that was really what motivated me in thinking about the School of Architecture as a project, because there is a transformation in a notion of discipline, I believe, that's being effectuated already, as you note, in practice. That would be worthwhile to tap into and to try to engage a little bit more profoundly.
I can only agree. I mean,
Yeah.
yeah. I mean, I got an email from Fried Ogenbraw, one of the faculty member here, just the other day, where Harvard just announced a joint degree between architecture and, I think, mechanical engineering. So, you know, schools are already starting to think about this, that, you know, architecture or any discipline simply can't stay in a silo anymore. And, but I still, and maybe it's just my naivety because I've only been here 2.5 months, but I still say that this is a place to be for that to happen. I think, you know, I absolutely think this is the place to be, yeah.
And Georgia Tech already has certain models already, you know, other, not to say, well, interdisciplinary sort of programs, history, science, and technology,
Yep.
literature, media, and communications is already interdisciplinary by definition.
Right.
So it's not like we're reinventing the wheel.
Right, that's right.
It's there.
Yeah, I mean, to go into a university that doesn't have that culture already would be,
Yeah.
would be decades before it's going to happen. But that foundation seems to be already in place here. Yeah. So maybe we should open it up if anybody from the audience has questions.
One or two, or we could also continue the discussion upstairs.
Okay. Is anybody dying to ask a question? And then if not, we can just go, okay.
How are you integrating the streetscape
Yeah, I mean, I didn't present anything explicitly about that. I mean, you know, honestly, in that area, we would probably be relying on a consultant to work closely with. I mean, I didn't present the work, but the branch library, the Glen Oaks Library, we worked with a very innovative landscape architect that's going to be here next semester, Kate Orff, Scape. And they developed, you probably saw the garden outside, it's a small community garden. And the whole concept behind that was that the pavers could be moved around, and so the idea behind it was that it wasn't a fixed kind of garden. It was a place that was supposed to engage the community to want to participate in the maintaining of the library. And so that was all about kind of community engagement, because that's the problem with these libraries. They don't have the staff to maintain any outside space. So you have to, again, strategically build in, through design, a kind of cue and a motivation and incentive and just a vision to get the community to be part of it. There's another library that we're working on that I didn't show that's very much about that. There's a whole block of City Street where we're transforming the street and the public plaza into an extension of the library. Yeah.
How would you describe your use of light in something like in the library, for example, or at the Columbia, the cafe space? I would interpret it as somewhat archaic. It's a well use of natural light, but I would like to hear your description of the way you use light in your work. It's like an Albert Alto, like sensation.
I'll take that. I'll go with that. I mean, you know, it's funny, I talk about all this technology, but, you know, there's still the kind of poetics of light that is deep in our psyche when we're thinking about it. There's the quality of space, the qualitative aspects of space. So, I mean, I think we do use light as a material, and we think about light as a material. You know, it's an interesting question in the context of my bias or how I kind of position my lecture, because it's all about, you know, using technology to create quality space. But again, this is something where I think it's a debate, a constant debate. You know, when you're using high levels of technology to generate architecture, does it not have any qualitative aspects? In other words, do you kind of engineer out qualitative attributes of space through technology? I don't think you do. But, you know, but I think that you could have a sensibility when you're using technology, say toward light, where on the one hand, you're reducing the amount of artificial light and power consumption in a building, but on the other hand, you're making it a beautiful space. That lower level of that library, they never have to use the lights in there during the day. And the light really is, I mean, it's pretty nice, if I have to say so. I mean, it's a really nice basement. I don't know if that answers your question, but I'll go with the Alto comparison. I'll just stick with that.
Anyone else?
I know that the AIAS wants to make a quick announcement, so why don't you guys do that, and then we can go up to the gallery. Anyway, I want to thank the students for doing this. This is great. Yeah, great questions.
Hi everyone, my name is Alicia. I'm the current president of the AIAS here. Just a quick announcement, next Monday we are having a panel discussion about the mentorship program we're doing with the AIA Atlanta and NOMA Atlanta. So if you become a member of one of the student organizations, then you get the chance to have a mentor, which could be a local design professional or architect here in Atlanta. So the event is next Monday in this auditorium at 6 p.m. So just everyone is invited to come and learn more about what we'll be doing with that. And then Jose, who's the vice president, and I will be at the reception if you have any more questions. Thank you.
Okay.